The kidneys are the primary organs of excretion. Excretion is the removal of metabolic wastes from body. Kidney performs many functions such as excretion of metabolic wastes, preservation of water-salt balance in blood and body fluids, maintenance of blood pressure, and maintenance of acid-base balance. The kidneys also produce erythropoietin, which is their own endocrine hormone. But do you know what is glomerular filtration rate, or GFR? Well, glomerular filtration rate is the volume of fluid filtered from the glomeruli into Bowman's space per unit time. When arterial blood enters afferent arteriole, blood passes through glomerular capillaries. The plasma is filtered from glomerulus into the Bowman capsule. That's why this process is called glomerular filtration, as filtration occurs through glomerulus into Bowman capsule. Filtration membrane is formed by 3 layers: glomerular capillary membrane, basement membrane, and visceral layer of Bowman capsule. First is glomerular capillary membrane. Glomerular capillary membrane is formed by single layer of endothelial cells, which are attached to the basement membrane. The capillary membrane has many pores called fenestrae, or filtration pores, with a diameter of 0.1 micron. Second layer is basement membrane. Basement membrane of glomerular capillaries and the basement membrane of visceral layer of Bowman capsule fused together. The fused basement membrane separates the endothelium of glomerular capillary and the epithelium of visceral layer of Bowman capsule. Third layer is visceral layer of Bowman capsule. This layer is formed by a single layer of flattened epithelial cells resting on a basement membrane. Each cell is connected with the basement membrane by cytoplasmic extensions called pedicles or feet. Epithelial cells with pedicles are called podocytes. Pedicles interdigitate, leaving small cleft-like spaces in between. The cleft-like space is called slit pore or filtration slit. Filtration takes place through these slit pores. This side has blood, while this side has filtrate. So, glomerular filtration rate is the volume of fluid filtered from the glomeruli into Bowman's space per unit time. The formula of glomerular filtration rate is total filtrate per unit time. In a 70 kilograms person, the glomerular filtration rate averages 180 liters per day, or 125 milliliters per minute. This is much higher than the combined net filtration of 4 liters per day of fluid across all the other capillaries in the body. When we recall that the total volume of plasma in the circulatory system is approximately 3 liters, it follows that the kidneys filter the entire plasma volume about 60 times a day. This opportunity to process such huge volumes of plasma enables the kidneys to rapidly regulate the constituents of the internal environment and to excrete large quantities of waste products. Forces involved in glomerular filtration are glomerular capillary blood pressure, which is favoring filtration, pressure in Bowman's space, and osmotic force due to protein in plasma, which are opposing filtration. Glomerular capillary blood pressure, which is favoring filtration, is 60 millimeter of mercury. Fluid pressure in Bowman's space is 15 millimeter of mercury, and osmotic force due to protein in plasma is 29 millimeter of mercury. So, net glomerular filtration pressure is 16 mm of mercury. Force opposing filtration have negative sign. Glomerular filtration rate is determined not only by the net filtration pressure, but also by the permeability of the corpuscular membranes and the surface area available for filtration. In other words, at any given net filtration pressure, the glomerular filtration rate will be directly proportional to the membrane permeability and the surface area. The glomerular capillaries are much more permeable to fluid than most other capillaries. Therefore, the net glomerular filtration pressure causes massive filtration of fluid into Bowman's space. Glomerular filtration rate is not a fixed value, but is subject to physiological regulation. This is achieved mainly by neural and hormonal input to the afferent and efferent arterioles, which causes changes in net glomerular filtration pressure. The glomerular capillaries are unique in that they are situated between two sets of arterioles, the afferent and efferent arterioles. Efferent arteriole constriction alone increase hydrostatic pressure and increase glomerular filtration rate in turn. Similarly, dilation of the afferent arteriole increases hydrostatic pressure and increase glomerular filtration rate. But constriction of the afferent arterioles decreases hydrostatic pressure in the glomerular capillaries, decrease glomerular filtration rate. Dilation of the efferent arteriole decreases hydrostatic pressure in turn, and thus glomerular filtration rate decrease. The control of glomerular filtration rate is an example of the general principle of physiology that most physiological functions are controlled by multiple regulatory systems, often working in opposition. In addition to the neural and endocrine input to the arterioles, there is also neural and humoral input to the mesangial cells that surround the glomerular capillaries. Contraction of these mesangial cells decreases the surface area of the capillaries, which causes a decrease in glomerular filtration rate at any given net filtration pressure. It is possible to measure the total amount of any non-protein or non-protein-bound substance filtered into Bowman's space by multiplying the glomerular filtration rate by the plasma concentration of the substance. This amount is called the filtered load of the substance. For example, if the glomerular filtration rate is 180 liters per day and plasma glucose concentration is 1 gram per liter, then the filtered load of glucose is 180 grams per day. Once the filtered load of the substance is known, it can be compared to the amount of the substance excreted. This indicates whether the substance undergoes net tubular reabsorption or net secretion. Whenever the quantity of a substance excreted in the urine is less than the filtered load, and tubular reabsorption must have occurred. Conversely, if the amount excreted in the urine is greater than the filtered load, and tubular secretion must have not occurred. So, this was all.
Explore our extensive library of over 1,800 video lectures to learn about a wide range of topics. Only on sqadia.com.